Thank you so much. And is the mic on? Is this working? Yes, it is. Fantastic. Awesome. Great. Well, thank you all for joining us after the coffee break. And I'd like to join the other speakers in thanking Ed and the other organizers in this just fantastic and inspiring workshop. I've been working a little bit in neuroaesthetics for the past 7 or 8 years or so, but to actually have a whole workshop, a whole meeting the idols, my idols of this field, is so exciting, and the conversations have just been rich and awesome, and I'm honored to be part of this. So in today's session, so far today, we're talking about embodied neuroaesthetics. And you guys are all here, you all have bodies, you're all sitting, you all have brains, you're listening, but I'd like to urge you, please, to get up onto your feet, because you do have bodies, and you're going to use these bodies really quickly, right at the beginning. Don't worry, you'll get to sit down again, but you're all standing. Okay, great. So let's just say hello to our bodies. We're into the morning now, and we're not just out of bed, but we've had our coffee, so please just join me in stretching your arms above your head. Just do a few reaches up, really just feel like, how nice is that to feel your body actually moving? Good stuff. Now, you don't have to do anything too crazy, but just kind of fold at the waist, bend over a little bit, drop your head, just let it kind of, I'm going to lose my mic, yes. Just let it kind of hang there. You can do some neck rolls, but just feel your body and feel how nice it is to move and to not just sit at your seat, at your table, and have your eyeballs glued to the screen. And just one more time, arms up, and you can just hold one hand like this and stretch up, and hold the other hand and stretch up, and arms to the ceiling, and take a great big breath. Exhale. Again, I'm losing my mic. And good, and you just shake it out a little bit, shake it out, and now you can sit down. Thank you for moving your bodies, thank you for having your, oh no, there's no applause for that, sorry.
Can I help you get this on here again?
Yeah, no problem.
There we go, is that too tight?
Nope, that's fine. Oh, much better, yes, Helmut conveniently missed out in the stretch session, but it's important, right? We have bodies, and our bodies are a really important part of our sensory experience, and I hope to convince you through some of the studies I'll walk you through today, and I know Beatrice has already started with this, and Cinzia this morning as well, that yes, our bodies and how we're experiencing the world with this thing that's not just a brain and eyeballs, how this is impacting our aesthetic preferences and our aesthetic experiences. So I'll also say a little bit more about bodies, because bodies, we have seen bodies a little bit before today. We've seen bodies in paintings yesterday. But most of the things we've been talking about in this workshop before today has to do with static artworks or static percepts, static stimuli. So we have paintings we've been showing people. Yesterday we talked about objects, we might have talked about graffiti, sculpture, but all of these things are static on a screen. And they tell us lots of interesting things, and we've learned lots about area MT+, and how implied motion can activate motion-type areas, and bodies in paintings and bodies in photographs can also activate body-selective regions. But I'd like to say that, yes, we want to now get to the real thing, to the bodies that are moving, the bodies that are in motion. I know that's still a photograph, but we're getting a little bit closer to what it is that I think is really interesting to study about embodied aesthetics, and of course, that's dance. So, kind of moving a little bit more so from the art percept that's static on the screen to the art object that moves, that's dynamic, that has all sorts of temporal elements to it as well. I'd like to place this interest in these research questions in a slightly broader context, and this is how we understand others moving around us. Now again, we've heard this in the first 2 talks this morning, that we kind of use our own experience, we use our bodies to make sense of others. Both Cinzia and Beatrice mentioned this idea of mirror neurons, or this idea of parts of the human brain that are responsible for linking up action with perception. And this is an idea that's now been around for some time, but the idea is really important because it sits at the core, I'd argue, of social cognition and social perception. And I'd also like to argue that art perception in many ways is social perception. There's something very social about art and very important and very meaningful for how we build cultures and how we build social relationships. But if we think about kind of, not necessarily just in artistic contexts, but in all sorts of other contexts, what we're doing from pretty much the moment we open our eyes in the morning until we go to sleep in the evening is we're watching other people move around us in a social world. Yes, we're also spending a lot of time looking at our phones and our devices these days too, but when we're not doing that, we're seeing others move. And it can be things that are really, really complex, such as watching a sports game, watching someone play a symphony, doing really complex joint actions like building a house, etc., dancing, etc., etc. But it can be really simple things as well. So what you guys just did now, and I had you stretch a bit, there's nothing terribly complex there, but you're still kind of linking up what your bodies are doing with what you see my body do up here. When you're raising your hand to ask a question, during these talk sessions, just walking from the hotel to here, all of these things require you to see what other people are doing around you and to coordinate your body and your actions accordingly. This is something that we absolutely take for granted. It's nothing that we have to really think about in great depth to kind of figure out how to do it. Okay, now I have to move my body here. It's something that we're highly evolved to do. But it's something I think that is really, really interesting and that helps us to understand our artistic appreciation as well. So coming back to this idea of mirror neurons, we've all heard about them. We're probably all sick to death of them. Mirror neurons were so, 10 years ago or whatever, but they still are a really important idea or an incredibly seminal discovery for helping us to understand how we are making sense of the world around us. But in my laboratory and with my research and with many others who are here as well, we kind of don't talk about mirror neurons per se, but instead we focus on an action observation network, which includes these brain regions where mirror neurons were first discovered. So we have the parietal, we have the premotor brain regions. This is where in the monkey brain, the actual cells, the mirror neurons themselves were found. But we're not looking at the human brain at a cellular level, of course. We're using much broader brushstrokes methods, such as fMRI, such as TMS, to get at these questions. So we're going to be talking about populations or assemblies of neurons, brain regions, and this is why I think talking about an action observation network, so a network of brain regions that are responsive when we see others moving around us is a perhaps more agnostic and a safer way of talking about things. But regardless of what you want to call it, the idea that has been around for a really long time is that actions are understood. We understand what others are doing around us through some sort of direct matching process of what we see others do onto the self. So there's this self-other, if not equivalence, this self-other resonance that's going on, and this is what helps us to understand what other people are trying to accomplish, are doing in the world around us. So what I've tried to do with my research over the years is to really look at this relationship between perception and action. And if we start at a really kind of simple bidirectional relationship, we have perception, perceptual analysis on one side, and we have action understanding or motor output. And again, I think like this really nice point that Moshe was making yesterday morning, we talk about perception and action being these really separate, really discrete things, but of course there's lots of overlap and there's lots of crosstalk between the two. But we know that there is a relationship, and we've known this. Aristotle was one of the first to propose that action and perception have some sort of privileged special relationship, and many veneered thinkers since then, revered thinkers since then, including Descartes, of course William James, and many other more contemporary psychologists. And this idea of motor resonance that kind of helps us build this bridge or kind of smooth the transition from perception to action is kind of the mechanism here. And again, the neural systems that underpin this that I've been really interested in looking at are these brain regions we call the action observation network collectively. And just, again, this is a cartoon representation. This kind of inflated brain here of the left hemisphere shows you the premotor cortex, the inferior parietal lobule extending along the interparietal sulcus, and the occipital temporal, and especially the posterior STS. These brain regions are kind of the core neural tissue that are involved when we're kind of making this link between action and perception, and importantly and specifically when we're watching others move around us. So what I've been trying to do over the past 10 to 12 years or so, is ask questions about experience and how experience shapes that relationship, that bidirectional relationship between perception and action. And we've done a lot of different things over the years. We've asked questions about physical experience, visual experience, social experience. This is something we're doing a lot more of now, such as whether another agent or action is human or artificial or robotic. Aesthetic experience, this is the big one for today, or affective experience, auditory and linguistic experience. So we ask all sorts of different questions about how if we give people, if we train people, if we know that people have a lot of particular experience in one certain domain, how is this going to shape how they're perceiving what others are doing around them? And of course, this question of aesthetic experience is the one that I want to focus on today. And it's not so much that we give people an aesthetic experience, as you'll see in these types of studies that I'm going to talk about, but it's more that this is the outcome or the output that we're most interested in, is what people's aesthetic experience is. So there's two ways that we're going to look at, that we've looked at in my lab, of how aesthetic experience shapes perception. And one of these is long-standing experience or long-standing expertise. So people come to the laboratory, they have spent years and years practicing some particular skill, in this situation, dance, and then we can capitalize upon those many, many hours of practice that people have already invested to understand how that's shaping their aesthetic preferences. And then what we also make a lot of use of is lab-based training. So we take people who are naive, who have no experience in this situation in dance, we bring them into the lab over many days, sometimes many weeks, and we teach them to do things. And then we see how this de novo learning shapes their aesthetic preferences or shapes their experiences. So I'll talk about, those are kind of two methodological approaches or methodological techniques, but we'll talk about kind of two different research questions today. The first one is this expertise question. So we're going to ask how action expertise modulates aesthetic evaluations at implicit and explicit levels. And then we'll really kind of dig in a little bit more depth with some training manipulations to questions about the relationship between aesthetics and embodiment. So what is this relationship between what we enjoy watching and what we can actually do with our own bodies? Does this matter, or is this completely, two orthogonal, independent things that are going on? So to begin with this question about expertise and the relationship between embodiment and aesthetics, we already heard from the woman herself, Beatrice, who just spoke, that there is some sort of embodied representation of expertise in the human brain for specific motor repertoires. So Beatrice and her colleagues showed this with looking at expert ballet dancers and expert capoeira dancers, and indeed they found that when the expert dancers were watching their expert dance style compared to their non-expert dance style, there was more widespread engagement of this action observation network. So really nice kind of first evidence to suggest that this is the case. And right around the same time, my group and I were doing a study also with expert dancers, but this was a slightly different study where we had all of our dancers come into the laboratory across 6 weeks of a rehearsal process where they were learning with their dance company a new dance piece, and then we scanned their brains on each Saturday throughout the 6 weeks of rehearsals as they watched this new choreography they were learning, as well as kind of kinematically similar choreography that they weren't actually learning. And we made some comparisons between the new motor learning that was happening and the control learning, or the control actions, and their perceived motor competency to perform these movements. And what we found, kind of nice corroboration of the work by Beatrice and colleagues, is that two core nodes of the action observation network, so primarily the left interparietal lobule and the left ventral premotor cortex, showed this really nice parametric response that they respond more strongly the better people are at performing movements that they see on the screen. So we have some nice evidence that yes, expertise, whether it's long-standing, whether it's kind of being generated during an experimental procedure, expertise is very much sharpening and shaping responses within this action observation network. So we want to know as well, okay, to what extent does expertise also shape aesthetic preferences and aesthetic responses? So what we did in this study, well, we started with this premise of knowing that when we watch other people moving around us, so it can be as simple as watching any of the speakers at this meeting walking along and presenting and moving their bodies, it can be something as complex and sophisticated as dance. But we know that when we're watching others in action, there are that there are subtle emotional responses that are being elicited, whether we're thinking about it or not. There's a really nice study that's mentioned here by Cannon and colleagues, where they simply just had people in a laboratory and they had them watch videos of people reaching to grasp household objects. So as, you know, perhaps boring as you can get, very dull, very reach to grasp, but people were either reaching to grasp them directly with no obstacles in the way, or they had to kind of make a funny reach around some sort of obstacle. And they find that, you know, when people are making these awkward grasps around obstacles, that perceivers, you know, their emotional responses to those are found to be very disfluent and not nearly as pleasant to watch as a much more fluent, direct grasp to objects. So this was kind of some of the nice first evidence to suggest that there's emotional engagement when we see more or less fluent actions, even if they're everyday actions. So we wanted to ask, to what extent do these subtle emotional responses, as well as explicit ratings of enjoyment, how much are these influenced by a viewer's expertise with observed movements? So to test this question, we used facial EMG. This is something that Helmut introduced yesterday with some of the work that he spoke about. But essentially, for those of you not familiar with it, it's a really nice technique. It's relatively easy to administer. You have two electrodes that are recording really subtle implicit muscle activity in the face. So you have a pair of electrodes recording from the corrugator, known as the frowning muscle. So this is the muscle that when you furrow your brow, it's strongly engaged. But even when you don't furrow your brow, but something's just a little bit unpleasant, but there's nothing that you can actually read on the face, you'll still get some really implicit subthreshold engagement of this muscle. And then, of course, we also record from the zygomaticus, or the smiling muscle. And again, you don't have to actually break out into a huge grin when you're watching something that you find pleasing. It can just be very subtle, non-visible responses that are pleasant that could lead to engagement of this muscle. So our participants for this study, we had 25 expert dancers who have had at least, I believe, 8 years of dance experience each, and then we had 26 dance-naive age and otherwise education-matched controls. And we had these participants watch a whole bunch of videos that looked like this. We had 80 videos or so of expert dancers. So we had ballet dancers, a male and a female, performing all manner of movements. There was ballet movements, there was contemporary dance movements, etc. Each one was 3 seconds long. And participants first just watched these movements while they were having these EMG recordings. There was no other task. They were simply passively observing. And then we had them watch all these movies a second time while making an explicit rating task. So they rated on a 1 to 4 scale how much they liked watching each of these movements. So it's really important to first have this implicit kind of no instructions viewing task, because this is really allowing us to get at people's kind of baseline, kind of naive aesthetic experience of these movements without kind of putting a lot of stuff on top and asking them to explicitly think about rating them. But of course, then we do want to know what people do later find pleasant to watch or more boring or less interesting to watch. So this is why we do have them make the explicit ratings later. And what we find in this study, I'll show you our results for our zygomaticus, our smiling muscle, and our corrugator, our frowning muscle, for our control participants and our dance experienced participants. And for our non-dancers, what we find is when participants are watching the videos that they later tell us they really liked compared to those that they disliked, we see that there's no real distinguishing across the 3-second time course of the videos on the screen between those that are liked or disliked in either the smiling muscle or in the frowning muscle. So essentially these muscles are kind of engaged to a certain extent, but they're not really discriminating or helping us to discriminate between people's aesthetic experience of these movements if you're dance naive. However, for our experienced dance participants, we see something a little bit different. Here we do see that in the predicted direction, EMG responses do dissociate for movies that are, for dance clips that are later ranked as liked. We see more engagement of the zygomaticus muscle, and for those that are later ranked as disliked, we see more engagement of the corrugator muscle. Now, these traces, these are significant differences, but you can see it's quite messy, and it's, this physiological data, it's kind of moving around a lot, and there's lots of variance in these responses. But we do see overall this experience by valence and liking interaction among our dancers and our non-dancers. So we have some nice evidence that having some sort of embodied expertise, general expertise. It's not necessarily expertise with these movements per se. It's just, you know, a history of dance experience really does shape the extent to which our experienced dancers are responding emotionally during their watching of these movements. So what we can conclude from these expertise well, this little bit of expertise data about aesthetics is that physical expertise, in terms of your ability to actually perform and observe movement, it does shape perception. We know that it sharpens responses within parts of the brain that seem to be implicated in linking up action with perception, and it also facilitates subtle and implicit affective facial responses when we're watching movements, both those that we find pleasant to watch and those we find less pleasant to watch. So that's kind of people coming to the lab with some experience already. This is what we can say from this. But what I want to spend a little bit more time on is talking about questions about this next point here, what's the relationship between people's actual physical abilities, ones that we can actually kind of get at a little bit more detail in the lab, either through training or through actually asking them about what they can do with their own bodies. And the first study we did with this, we weren't quite into training yet. We were still having people watch videos that they weren't actually learning to do themselves, but we were asking people about their physical abilities to perform movements. So in this fMRI study, what we did is we had a group of participants come to the laboratory and we had them watch a whole bunch of these exact same videos you just saw of these professional dancers, male and female, performing a bunch of 3-second ballet or contemporary dance movements. And after each movement, they were asked one of two questions. So they were asked either, how much did you like watching this video? How much did you like the movement that was in this video you just watched? And again, I appreciate this is a 1 to 4 response. We're somewhat limited with what we can ask in the scanner. We can do better. I'm taking lots of notes on everyone who's doing work with kind of more continuous response scales, or far more subtlety in giving responses, so it's not just this kind of forced choice here. So we ask our participants either, how much did you like watching that video you just saw? We asked them, how well could you perform the movements you just watched? And they never knew after each video whether they were going to be asked the like question or the perform question. But throughout the whole experiment, we were able to get a rating for each video from each participant about both how much they liked each video and how well they could perform each video. And in this particular experiment, we had 22 dance-naive participants, so they aren't dancers themselves, they're just kind of dance spectators, not professional dance spectators, they're just people who are watching dance. And we're now able to kind of look at whether there's some sort of relationship between what you like doing and how well you could actually do it. And the first thing we found that was quite interesting, and I'd be really keen to talk about this in the discussion with all of you who are interested in similar sorts of questions, but we find this really strong negative relationship. And what we see is that people really like watching those movements that they cannot do themselves. So this actually makes a lot of sense if you think about it. As we talk about in this paper and in several review papers since, we term it perhaps somewhat cheesily the Cirque du Soleil effect, but we pay money and we like to watch things that we can't do with our own bodies. This is why we go to see NBA games, why we pay to go to Cirque du Soleil, to the professional ballet, et cetera, to see people whose bodies are doing things that are so remarkable that you just can't get up on stage and do yourself. This makes a lot of sense, and we get this really strong negative correlation here. But this is interesting as well because, of course, we've heard this from the first day here that familiarity also breeds liking, and there's lots and lots in the empirical aesthetics literature that talks about how, and advertisers make huge use of this, that get people really used to something and they'll like it because it's familiar, it's comfortable, we have perceptual fluency, it's easy to process, but we also have this relationship going on as well. But then we also asked, okay, is there something in the brain that's kind of showing this relationship as well? So we asked, is there an interaction? Are there any regions that show this interaction that show a stronger response when you watch those videos you like a lot? So you give them really high liking ratings, but you give them really low reproducibility or performability ratings. So we did this parametric analysis this parametric interaction. And what we see here, quite interestingly, is that when you see movements that you really like a lot, but there's no way you can do with your own body, or when you rate movements as increasingly likable and decreasingly physically possible for you, here we see bilateral occipital-temporal kind of visual regions, later visual regions, but also this really kind of quite clear engagement of the right interparietal cortex. So what's quite interesting about this is that this is kind of one of the core action observation network regions, which lots and lots of literature suggests that embodiment, like when you see stuff you can do, when you see stuff that your body has done before, this region is really, really engaged. Here we see people cannot do these things. This is becoming more active the worse you are at actually doing it. But when you really like something, this region is coming online. So it seems to suggest that it's not just kind of sensory motor resonance that's really engaging these brain regions, but it's also something else, including an aesthetic or an affective response that's kind of getting these sensory motor brain regions active. So what we've done since then is quite a few follow-up studies where we don't just ask people how well they can do things. We actually are now testing them, and we're training them to perform different dance sequences. So to do this, we've not used, again, this beautiful motion capture, these suits that we saw in yesterday evening's demonstration, but instead we're using a straight out-of-the-box Xbox Connect system with a dance training video game, and we have participants stand in front of a large screen TV while their motions are tracked and their silhouettes are matched to a performer on screen with what they're doing themselves, while they learn a whole bunch of different kind of fun street dance videos. And I'll show you some examples of some of the videos. Now, the videos I'm going to show you are just snippets that we use for the actual study. When you're in the actual training study, though, these will be about 1.5 minutes long, so these are just small pieces of those longer pieces. So I think that's Guido's favorite song. He always wants to dance to that. Isn't that right, Guido? And oh, it's hot stuff. Of course it is. So yeah, so there's all sorts going on in these. Obviously, it's very, very rich, and in some ways, it's very ecologically valid because it's an actual video game and people are dancing to music. But of course, when I speak to dance crowds, people hate this because it's not real dance. We're actually, maybe it's someone in this room. There's a reviewer we're arguing with right now, talking about how this isn't actually dance. But look, the video game's called Dance Central 3. I'm not sure what else you need here. But it is music, it's movement, and what you see in these clips are just kind of small, discrete movements, but of course there's long chains of these. And it's very engaging, and it's a lot of fun for participants. And when you're doing training studies, that's actually an important consideration, because you want people to be motivated to learn and to come into the lab day after day and to do these performances, to perform these sequences, and to actually learn something. So in these types of studies, what we do is we have identical fMRI sessions that sit on either end of 4 days of behavioral training. And we don't just have people kind of come into the lab and dance these sequences. They will do that for a fair number of sequences, but we also do various manipulations. We'll have them just sit and watch the music videos and listen to the soundtracks. This is our visual and auditory training, or just sit at a computer and listen to the soundtracks so they become really familiar with some of the music, but they don't actually see any dance movements associated with them. And we'll have different dance sequences for each of these 3 training categories, and we'll have a fourth one which remains untrained. And the reason for having these different types of training interventions is because we can then start to get at, okay, what is it that might shape your aesthetic response? Is it actually doing the dance itself? Is it just having the music and seeing the movement on screen? Is it just something about the music? Or do you actually like stuff when you don't have a lot more experience with it? So this is why we have the untrained condition. And then we can also have people come back in after all the other testing procedures have happened and have them perform all the different sequences, so those that they've trained on in the 3 different training categories, as well as the untrained ones, so we can look at questions about how much learning generalizes. And what we've seen in these studies behaviorally is that okay, this is our data from the post-training dance retest. And in the red bars, we have videos that people's performance and how well they dance those that they physically practiced. So yes, they dance those very well, not a surprise. In orange, we have those that they just watch the videos and listen to the music, so not nearly as well. Yellow, just the listening to the soundtrack, the auditory version, and green, untrained. So we see, okay, yes, not a surprise that people are performing overall much better on those that they physically practice, but there is a little bit of observational learning going on. So they are performing those that they've just watched a little bit better than the untrained ones. But most interestingly for this crowd is what's going on with people's liking ratings. So we have people rate all these videos, all these little dance clips like I just showed you a pair of. We had them say how much they like these before they've done any dance training, and then after they've done dance training. And what we see, we also ask them how well they can reproduce, and we do link this up to actual performance ability, but I won't get into that here. But what we see is that those videos that you've spent a week learning to dance, or the ones that you just watched, you actually like those substantially better, significantly better after the week of training compared to before. So there is some, again, this is the more typical aesthetics effect that's reported in the literature, is that experience does make you enjoy these movements more. You do like watching these movements more after that. And in terms of what we see in the brain, we're going to look at some pre-training and post-training engagement of the brain here, and these are also some parametric analyses. These are kind of like what Ed showed yesterday, so we're looking at brain regions that are showing a stronger response when you give that 4 rating for really liking those videos compared to the 1 rating, and kind of progressively stepping up. So for the pre-training, we see more engagement of these kind of subcortical regions, the subthalamus, the nucleus accumbens. These are brain regions that have been implicated in other literature with processing pleasure. So we kind of have these, they're not motor regions per se, they're much more kind of middle brain or more deeper brain, pleasure-associated regions. But after you've had a week of training, what we see is that parts of the right STG and bilateral STS, so that kind of the aesthetic response migrates outwards. It migrates out to brain regions that are more interested in multisensory integration, in perhaps embodiment. So we kind of see this shift from kind of more general pleasure responses to more kind of embodied perceptual responses. And again, this is one study. It is an interesting finding. I definitely want to replicate this before saying that, okay, this is something really meaningful and this is a pattern we're going to see again and again. But it is, I think, interesting. And I'm going to wrap up in just a second here. I'm just going to talk about kind of 2 future directions that we're continuing to carry on to kind of explore a few more questions along these lines. And one is some work that was done by Louise Kirsch, Louise sitting right there, which you can hear a little bit more about in the poster session a little bit later this afternoon. And one of the things that Louise wanted to look at was, okay, well, we have all this research that's done on university-age students, and that's great. We're interested in how people perceive dance when they're, young, healthy, fit university students that are convenient to sample in our psychology experiments. But what about other populations? What about, young teenagers who also, are learning to move their bodies and are still undergoing a lot of development? And also, what about older adults? These are people who also are great aficionados of the performing arts and the visual arts. Like, what's going on with these people with embodied aesthetics? Can we begin to ask some questions about lifespan development? So for one study, we did just this. We were kind of testing young adolescents, so these are 11 to 13-year-olds, I believe, and with older adults, these are people above the age of 65. We were testing a sample of these 2 specialized populations and also our normal convenience sample to ask a few different questions, but we were able to ask some aesthetics questions as well. So pretty much with that exact same experimental setup I described in the previous study, we had our older adults, our adolescents, and our young adults physically train, just visually train, or remained untrained, some of these dance sequences. And really nicely, this is just the pre-post aesthetic ratings, we see that quite nicely that our adolescents are our lightest bars here, our young adults are the middle bars, and our older adults are the rightmost bars, that all of our participants are kind of showing a similar sort of pattern, that they are liking things more after visual and physical training. But interestingly as well, our older adults, even though from our experience, they didn't love the street dance music, they didn't love, doing all these moves like this to the video game, but they did, they showed some of the most remarkable increases in aesthetic ratings after being engaged. So I think there's some potentially interesting points about outreach here for getting older adults especially involved in these sorts of embodied paradigms like this. The imaging data, they're complicated. I'm not going to get into this in great depth, but I will say, see Louise's poster because she will talk you through it, and that is what that says there. And last but not least, also working with Guido and Andrea, who's also here, doing some really interesting and lovely work with some stimuli we recorded actually here in Frankfurt with a dancer from the former Forsyth company, Riley Watts, where we're asking some questions about temporal dynamics and how dances are actually performed and the relationship between embodiment and reproducibility. So that video you just saw was our dancer performing a piece of choreography one way, and this is the same dancer performing that exact same piece of choreography with pretty much all the temporal dynamics taken out. And again, we, as every other group working in aesthetics, we have this tension between ecological validity and experimental control, and the reason we like these videos a lot is because they aren't doctored, they're not manipulated. Well, these ones aren't. Guido might tell you about another version of these which are doctored. They are the dancer being given the choreographic instruction to perform the movement dynamically as intended by the choreographer versus take out all of the dynamic information and show us what this looks like. And this allows us to get at some questions about how naive observers are really kind of processing this temporal dynamic information in terms of their aesthetic response. And again, Andrea is going to be talking about some of the first part of that study a little bit later this afternoon, so feel free to drop by and see that. All right, so wrapping up, what have we learned? So the main research aim I've hoped to tell you a little bit about today is exploring how different kinds of experience shape not just social perception overall, but our aesthetic perception and our aesthetic preferences in general. And what's going on when you're seeing a person move, among many other things, your brain's calculating answers to the questions, can I do that? Have I seen this before? Do I like this? All of these things are kind of informing the engagement of sensory motor brain regions like those you see in the bright colors there. And in a nutshell, our findings suggest that, yes, our prior experience profoundly shapes how we perceive others, but it's not just in this general linking action with perception sense, but it's specifically as well in an aesthetic or affective sense. I also think it's interesting how some of our findings do challenge this kind of direct matching sensory motor resonance hypothesis, where the more familiar something is, the more we engage these brain regions. We find that it's not just familiarity, that aesthetics, that really liking something can also really drive these brain regions. And that's interesting. I don't know what it means. I have some ideas, but it's just, I think, a really interesting point of departure. So we're doing a lot more along these lines. We're continuing to explore how this experience-dependent plasticity is shaping and changing our preferences. And we're also hoping to kind of use some of this information we're learning about movement preferences and how we perceive movements in others, and kind of applying this to robotics design as well, in the aim of hopefully optimizing human-robot interaction and intention reading of artificial agents' motions. So I'd like to thank all of some of my fabulous collaborators and colleagues and funders there. And of course, thank you guys for listening, and very happy to take questions. And yes, we're recruiting for a postdoc, so if anyone's looking for a robotics postdoc, get in touch. Thank you.